In this lecture, we'll explore the use of the reduce method in Python's functools module, a powerful tool for summarizing and processing collections of data. Its usage can be understood as the process of combining elements of a collection using a specific operation to yield a single value. Common examples of these you may already be familiar with, such as those including, for instance, calculating sums, products, averages, and statistical measures like variance. Let's try to understand a bit more how the reduce function actually works. It involves combining a sequence of values into a single value using a specific operation. This is what the reduction process is referred to, taking a number of values and decomposing them or reducing them into a single value for a particular purpose. These operations can be arithmetic, like addition or multiplication, or logical, like finding maxima or minima. The general syntax of the reduce function is reduce, followed by the function that performs the reduction, the iterable, and the initializer. It takes three arguments, as you can see. A binary function that will be applied to the sequence of values to be reduced, and an initial base value. For example, in practice, to compute a product of a list of numbers, for instance, you would use the reduce function with multiplication as the binary operation and 1 as the base value. In terms of practical examples, processing a stream of log data to find the total number of error messages is a good example of how reduce could be used in a streaming log processing context. In this particular case, you could use the reduce function with addition as the binary operation. Next, in genome pattern recognition, for instance, you might need to count specific nucleotide patterns in a DNA sequence. Reduction could simplify this process. And finally, in stock price anomaly detection, detecting anomalies in stock prices over a period of time could involve reducing a dataset to certain statistical measures like variance or averages, which would help in identifying outliers. There are certain considerations and best practices that need to be kept at the forefront when using reduction in general. Firstly, efficiency. It's essential to consider the efficiency of the operation used in reduction. Complex operations, for instance, within a reduction can significantly impact performance. Then there's error handling. When working with functions like max or min, handling empty sequences is vital to avoid errors, for instance. And finally, in terms of readability, while the reduce method is powerful, it can sometimes make your code less readable. So it's important that you strike a balance between efficiency and readability and not just jump straight into a reduction based task if it could be handled in a more efficient and perhaps even more readable way. In conclusion, in this lecture, we've learned what reduction is and how it's applicable in a wide range of scenarios in data summarization, from simple arithmetic operations to complex data processing tasks. Let's now head over to the hands-on coding session